Hello and welcome viewers, I'm Pia and you're watching NewsX. Now India's space ambitions have just received a major boost. In a significant breakthrough that could shape the future of the country's space program, the Indian Space Research Organization, that is ISRO, has successfully completed a crucial hot test of its next generation semi-cryogenic engine. At first glance, it may sound like just another technical experiment inside a test facility. But in reality, this is one of the most important milestones in India's quest to build more powerful rockets, launch heavier satellites, undertake deep space missions, and ultimately send Indian astronauts into space on Indian technology. The test was conducted at ISRO's propulsion complex in Mahendragiri, Tamil Nadu, where scientists successfully fired the semi-cryogenic engine power head test article, or the PHTA, at a thrust of 175 tons. This is a massive achievement. To understand why, let's first understand what was being tested itself. The power head test article is essentially the heart of the engine. It includes almost all of the engine's critical systems such as the pre-burner, the turbo pumps, pipelines, valves and control systems. The only major component not included in this test is the thrust chamber, where the final combustion takes place. Now, by testing the power heads separately, ISRO can verify that all the engine's most complex systems work perfectly together before moving to complete engine tests. This latest test was the 8th in an ongoing series of hot tests. Each test has been designed to gradually push the engine to higher levels of performance. The first set of tests were conducted at 94 tons of thrust, around 47% of the engine's full capacity. Then came tests at 120 tons, or about 60% of its rated thrust. Now, for the very first time, ISRO has successfully operated the engine power at 175 tons of thrust, nearly 88% of its target output. This is in fact a huge leap. Even more importantly, the entire test went exactly as planned. During the test itself, they generated outlet pressures of 400 and 500 bar. To put that into perspective, that is hundreds of times greater than the pressure found in a car tire. It demonstrates the extreme engineering precision required to build a modern rocket engine. ISRO has stated that all the engine parameters remained well within the expected range throughout the firing. There were no major anomalies, and the main turbo pumps, which are responsible for pushing fuel and oxidizer into the engine under extreme pressure, performed precisely as designed. Let's listen in to what the chairman of ISRO had to say.
ISRO is entrusted with the responsibility of a 200-ton engine working with liquid oxygen and kerosene. So what the test done was, except the thrust chamber, we call it as a power head test, the turbine, pump, every system. We have taken to close to 90% of the thrust level because we are going step by step. It was a major achievement and milestone, and now we are getting ready.
The success of this test has now given ISRO the confidence to move to the next major milestone, testing the engine at its full rated thrust of 200 tons. Once that is successfully completed, India will be much closer to having a fully operational indigenous semi-cryogenic engine. But why does this engine matter so much? Now, the answer lies in India's future space missions. The engine, known as the SE-2000, will power the new semi-cryogenic propulsion stage called the SC-120. This new stage is being developed to replace the existing L-110 liquid core stage on the LVM-3, that is India's heaviest operational launch vehicle. It will also serve as the launch vehicle for India's Gaganyaan human spaceflight mission. Now, with the new SC-120 stage, the LVM-3 is expected to become even more powerful. It will be able to carry heavier payloads, launch larger satellites, deliver more scientific equipment into space, and do so with greater efficiency. This means that India will have greater flexibility for both commercial launches and strategic missions. India's latest semi-cryogenic engine milestone represents a significant stride in its indigenous rocketry ambitions. While impressive for ISRO, it sits in the mid-tier globally. Russia's RD-170 family still reigns supreme with around 740 tons per engine, and the historic NASA Saturn VF-1 delivered about 680 to 700 tons. SpaceX's Raptor 3 generates roughly 250 to 280 tons per engine with superior reusability and efficiency, while Blue Origin's VE4 pushes near 290 tons. To simplify this, if Indian engines can lift off a fully loaded Boeing 747 at 200 tons of thrust, SpaceX's Raptor 3 can lift off a 1.5 fully loaded Boeing 747. Russia's RD-180, on the other hand, can lift off two Boeing 747s, and USA's Saturn V F1 can lift a whopping 4 fully loaded Boeing 747s. Now, from Chandrayaan to Mangalyaan, from Aditya L1 to Gaganyaan, ISRO has repeatedly demonstrated that India can develop world-class space technology through indigenous innovation. For India's space program, this is far more than a successful engine test. It is the sound of the next generation of Indian rockets coming to life. This is the latest that, of course, we are getting to know as far as India's space ambitions are concerned. This rocket is crucial to ensure that India's Gaganyaan space mission, which will be launched via the LVM-3 rocket, will manage to gain success. The Powerhead test article is the heart of this particular engine. It includes almost all of the engine's critical systems such as the pre-burner, the turbo pumps, the pipelines, the valves, the control systems, and the only major component not included in this particular test is the thrust chamber itself, where the final combustion will take place. Of course, this final testing that has been held, ISRO can verify that all the engine's most complex systems work perfectly together before moving to complete engine tests. With us on the broadcast is Dr. Raju Gurachandar, former ISRO scientist. Thank you so much, sir, for taking out the time and speaking to us on NewsX. How crucial is this semi-cryogenic engine test for India's future spaceflight missions, including the Gaganyaan mission?
Good evening. I'm happy to be sharing some of the points which would like to highlight a few of these things. It can carry a higher payload and also safety. There's a better safety in this mission because normally to store all these propellant material in the launch complex like Sriharikota, it is more safe to have a combined semi-cryogenic, which means liquid oxygen plus kerosene. Normally, we call it even ISRO-CENE, ISRO-CENE to a nomenclature dubbed as ISRO-CENE, which is nothing but a combination of the propellant, liquid oxygen, as well as oxidizer. Together, it's easy to store in our launch complex in Sriharikota. So there's a safety aspect is built into that, more power into that. And we are looking forward to the final stage of whatever it can carry more, 170 tons now, up to 200. I think it can be taken, it can replace some of the currently available S110 engine with this cryogenic, semi-cryogenic engine. We were looking forward to using it for a Gaganyaan mission. It's a very powerful mission, very important to have a higher payload capacity. And as you all know, the kind of technology available is very, very limited. It's a highly secure technology, not available easily, not available in the literature. So we are, personally being an ex-ISRO scientist, I feel very happy, proud that we have achieved this very important milestone in the launch vehicle. Thank you.
Absolutely, sir. And just one quick follow-up to that. The L110 liquid core stage on the LVM-3 is now going to be replaced by the SC120, the new semi-cryogenic propulsion stage. For the benefit of our viewers, can you really explain in just simple terms, what does this replacement really entail?
Basically, a rocket engine consists of three parts. Number one is a pump, which pumps the the propellant as well as the oxidizer into a combustion chamber. So it gets mixed up and there is a pressure, a thrust developed in the chamber the thrust passes through the rocket nozzle, and this is a very powerful, very important portion. All these things can be handled a better way. I'm talking about three parts. I will repeat it. First one is the pump, to pump the liquid oxygen as well as the oxidizer together into the combustion chamber. And the in the combustion chamber, the pressure builds up because of the burning of the two items, that is the oxidizer and the oxygen as well as the propellant itself, and pushes through the nozzle. And the nozzle is the one which converts the high thrust into a big escape, big velocity. That is called the nozzle velocity, and that is the trick of the total. Though we say rocket science, it's very easy to understand these three parts. It is just like a simple propellant mixed with oxygen, oxidizer, burnt into space. Why do you need oxidizer? Because when you go into the space, the combustion cannot take place without the presence of oxygen. So this is a fundamental thing, and these two together will make a great combination. And we are very lucky that with all the the basic tests have been completed recently, as also reported by our ISRO chairman, and we are looking forward to the final thrust, that is normally going to happen in Trivandrum, Mahendragiri, IPRC, Indian ISRO's Propulsion Research Complex, IPRC. Okay, therefore, that is very, very crucial for Gaganyaan, because we need a higher payload capability, higher altitude, and higher tonnage. The weight of the total thing will be higher. So we have to test this. We are planning to test it. I'm sure it will be very successful, because it has successfully performed as expected till today. Recently, we had this hot test, so-called hot test, and I'm sure we are in the right direction. And I wish and hope, and I'm sure that this will be successfully done.
Absolutely. All 1.4 billion Indians are wishing for the same. So with that, I'd like to thank you for taking out the time and speaking to us on NewsX Deep Dive. On that note, we dip into a quick short